White salt is not just a familiar addition to the kitchen table. It is a product that has accompanied humanity for thousands of years. It plays a role in cooking, medicine, industry, and even energy. It is used in food production, preservation, water purification, pharmaceuticals, and cosmetics. But how exactly does this crystalline mineral turn into pure, snow-white salt, ready for consumption? Today, we will step inside a modern factory where traditional knowledge meets cutting-edge technology. The use of salt spans thousands of years. In ancient times, white salt was obtained manually by evaporating seawater or collecting crystals from salt lakes. Today, most white salt is produced from underground salt beds formed millions of years ago when ancient seas dried up. These deposits lie at depths ranging from hundreds of meters to a kilometer, accessed through special boreholes. Modern white salt production begins with a method called solution mining. Powerful pumps inject water at high pressure into boreholes drilled directly into the salt beds. When the water comes into contact with the mineral, it begins to dissolve the salt crystals, turning into a saturated salt solution, brine. This process forms massive cavities within the deposit, filled with water. The extracted brine is pumped to the surface through pipelines and sent to purification facilities. Here begins the first stage of transforming the cloudy, mineral-rich solution into a crystal-clear product. Natural salt always contains impurities: calcium, magnesium, iron, and other minerals. To produce pure white salt, the brine passes through a system of filters and chemical treatment. Special reagents are added into reaction tanks to bind unwanted impurities, turning them into sediment. The sediment is removed, and the transparent, purified brine is pumped to the next stage: evaporation units. In countries with hot climates, brine can be evaporated using solar heat, but in industrial production, vacuum evaporators are more common. These are sealed cylinders where the pressure is lowered, reducing the boiling point of water. The brine enters the first stage of the unit and begins to boil at a relatively low temperature. Small salt crystals form during the process, becoming larger with each subsequent stage. The steam released in the first chamber is used to heat the next, significantly saving energy. At the end of the evaporation process, we obtain a thick mixture of salt crystals and concentrated brine, known as salt slurry. The salt slurry is fed into powerful centrifuges. Rotating at high speed, they separate the salt crystals from the liquid using centrifugal force. The centrifuge produces moist, but already fully formed white salt. However, for use in the food industry, the moisture level is still too high. It must be reduced to a minimum. The salt is sent into fluidized bed dryers, large chambers where hot air flows around the crystals, completely removing residual moisture. In some cases, manufacturers add anti-caking agents at this stage to prevent the crystals from clumping during storage and transportation. After drying, the moisture content of the salt does not exceed 0.1%. This is the form of salt that moves to the packaging lines or storage facilities as a finished product. Before the salt is packaged, it undergoes multi-stage testing. Factory laboratories check each sample for purity, crystal size, and absence of impurities. If the batch meets standards, it is sent for packaging. If not, it is returned for reprocessing. After drying and quality inspection, the salt moves to vibrating sieves for sorting. Here, it is separated into several fractions depending on crystal size. Coarse salt, used in cooking for curing, marinades, and dishes where a pronounced crunch is important. Medium fraction, the familiar table salt, suitable for everyday use. Fine grind, used in the food industry for making snacks, baked goods, and sauces. For some markets and customers, the salt is additionally iodized. This process helps combat iodine deficiency and is strictly monitored according to medical standards. The sorted salt travels via enclosed conveyors to the packaging lines. Factories use different types of packaging. Small packets of 500 grams or 1 kilogram for retail consumers. Bags of 25-50 kilograms for restaurants and food manufacturers. Big bags weighing up to a ton for industrial applications. Modern packaging machines dose the salt with gram-level accuracy to ensure every package has the exact specified weight. Once filled, the bags are hermetically sealed, and the production date and batch number are printed directly on the packaging. Finished products from the conveyor go to palletizing. Automated palletizing robots stack the packages, wrap them with stretch film, and send them to storage. Each pallet is labeled with production date, batch number, country of origin, and even a QR code to track the product's journey from factory to consumer. Salt can be stored for years if the proper conditions are maintained. In factory warehouses, a dry and stable microclimate is ensured. Air humidity is controlled by automated systems so the crystals do not absorb moisture. Products are placed on wooden or plastic pallets so that the bags do not touch the floor and take on moisture. White salt is a global commodity, and its logistics are fine-tuned down to the smallest detail. For domestic deliveries, covered trucks are used. For international shipments, sea containers, or rail transport. At large factories, product dispatch operates around the clock. Every truck or container undergoes document verification to confirm it contains exactly the batch that was ordered. While in daily life we most often use salt for cooking, its role is much broader. Food industry, from canned goods and cheese to bread and sausages. Chemical industry, production of plastics, detergents, and reagents. Pharmaceuticals, saline solutions, medicines, and medical preparations. Cosmetics, scrubs, bath salts, and skincare products. Factories often produce goods for several industries at once, so the packaging lines can handle different types of packaging and labeling simultaneously. The journey of white salt is a chain of complex technological processes that combine geology, chemistry, engineering, and automation. From deep underground deposits to a neatly packaged bag on a store shelf, every stage is fine-tuned with precision. White salt is more than just a culinary seasoning. It is a strategic product, vital for health, industry, and the global economy. And now, knowing the entire path of its production, you can look at these tiny white crystals with new respect. A mineral that, century after century, remains one of the most valuable to humankind.